How's it going, everybody? We're back. Wednesday. Another Houdini stream. So today we're going to be doing still kind of on the general thought of destruction. But this is going to be doing fracturing. We're going to do some cutting and fracturing, destroying, slicing, all of that good stuff with Houdini. So we'll be doing some Boolean operations. Whoops, the wrong command. We'll be doing some Boolean operations, Voronoi fracture, covering both of those, and some bullet RBD simulation. So Houdini, since I forget when they released it, it might have been 15. I think 13 was when they first had packed primitives. And then they've been upgrading or just optimizing their implementation and everything of that since Houdini 13. Let me just get my windows. So this was something I'd done a while back that was just like a performance check or whatever for packed primitives. So just testing and seeing how many pieces I could do at the same time and how quick it would run and stuff like that. So this was like, I forget how many pieces I did, but even something like this, it only took like 10 or 20 minutes or something like that, or not even that, like 10 minutes for each frame to solve. So it's super powerful. You can even, like at the end of it, you see this is almost like a fluid, like a grain simulation or something like that. So you could get well over millions of rigid body pieces and simulate them really efficiently with that workflow. So what we'll do is just go into the geometry and different objects. I'll just get started with the grid. And we'll start just looking at different ways that we can fracture this. So the original method that Houdini had was always this Voronoi fracture node. This is a digital asset that it does a bunch of stuff inside of it. It has almost too many options in my opinion, maybe. If you look at the Voronoi split, this is like the underlying feature or node or whatever that's used inside of this digital asset. I think they moved some stuff around on me, but somewhere inside of here you would see that here it is. Cut each piece. So this is the one that actually does the slicing or the changes the geometry. If you're familiar with Voronoi tiling or shaders or stuff like that, it's all kind of the same pattern and it's the same math. So if you have just triangulate for a 2D point cloud, then you connect the nearest points like that, and then wiring this up like that, you'll get the cut up grid. So we could go into 2x2 rows or whatever to I'm just getting rid of the divisions before I've cut it. Then if we have a 3D shape, just like a box, we can do the same scatter. I usually just turn off the relax iterations to get like a slightly more random distribution. And then if you just do the tetrahedralize node, but set it to the output connected polylines, then this can be used as well for cutting and fracturing. So 3D geometry over here and 2D geometry over here. this guy is smart enough inside of it to know whether it's a 3D or 2D input, so it will automatically switch depending on what you give it. But I usually find that stripping out like all the extra stuff that's happening in there with groups, when you start to fracture really high point counts and stuff like that, these workflow will go faster. So if I plug the two of these in, you can try, it's going to be 100,000 chunks. So each of these points becomes a cell center, or essentially a chunk. Like each fracture point represents one of those. So you can see how long that took. It took maybe 10 seconds or something like that. And then this guy right here goes a little bit quicker. For whatever reason, this time report doesn't work that well for digital assets. Like it's not smart enough to cumulatively acquire all the time that's happening inside of it. So unfortunately, you can't middle mouse button on digital assets or collections of nodes like subnetworks to get an accurate time report. But you could try this out yourself, and you see maybe it's a little bit faster for what you're trying to do. So we can fracture things in pretty interesting fashions using these two nodes. If you use the exploded view, this is a nice, I think I had a digital asset that I made that was a different one. So this is a very useful way to visualize the result of your fracture. You can see here that there's nothing happening inside of it. It's like a shell, a hollow object that we've fractured. So if I turn on create interior surfaces, it doesn't look like there's anything, but what's happening is my box has vertex normals that have been added to it, and then I fractured it, and the new geometry that's created isn't being assigned any normals. So I could recalculate normals for everything. The downside of doing that is that sometimes this will create some artifacts or some seam lines that might be visible, because I'm basically overwriting or recomputing all of the normals, even the ones that were already correct in the first place. So if I want to fix that, one of the things that's handy about this node is that you can create these attributes when you fracture things. So if I open up my geometry spreadsheet, you can see now I have piece numbers. So this corresponds to the point number that created the fractured chunk or fractured cell. And then it has the clip point attribute as well. So these, you see some -1s in here, and that -1 attribute, or the clip point attribute, can actually be somewhat useful. So if I do another color, I might want to just do random from attribute, and then if I do clip point, it looks like nothing changed. But if I again use this, so one thing I need to make sure is it's a primitive attribute. But still, before I explode it, it looks like nothing changed. And then you can see now the clip point attribute varies on the inside of the shape. But on the surface, it's always going to have a value of -1. So knowing that, when I compute the normals after the fracture, I can make a group using that attribute. I think, let me just make sure here. I think that's what I want to do. So I'm basically, with this exclamation point, I'm saying anything that doesn't have a clip point equal to -1, recalculate or compute new vertex normals. And then I can be sure that my shading is proper all the way across everything. So that's just a useful trick or whatever that I like to do with using these attributes that get generated by these pieces. And then the more advanced ones, more recently with Houdini, they introduced the Boolean node. That's a pretty useful technique to fracture things. So you'll notice with these, we always have straight lines that represent the cells. There's also this visualization of Voronoi that I was looking at when a different digital artist generated this pattern with like a plotter that will basically draw out computationally generated pictures. So you'll see that the Voronoi fracture, the construction is always straight edges. So if we want to get away from that, we can use the Boolean node. And again, they created something here that is kind of like this Voronoi fracture. It's got everything wrapped up inside of it. We could go, usually I just like to use the lower level nodes. So the Boolean one can do all the different operations. But instead of taking a point cloud in this other input, it's looking for cutting geometry, like cutting shapes. So if we have a box, we can use a grid. And then we can use that to do the cutting operation. So this shatter is usually the most useful for fracturing stuff using the Boolean node. It has some other things, like if I make a sphere, I can do more of what the actual icon looks like. So if I just grab my sphere, move it over, kind of like that. You can see using the shatter, what it's doing is using this as a cutting shape. But I could also do union. That's going to merge the two together. Intersect. Subtract. And there's also custom. This one's pretty complicated. I don't really use it that much. So shatter is what it's a good go-to for cutting things. And then we have all of Houdini's kind of nice procedural workflow or modeling that we can use to create interesting cutting shapes. So instead of a grid, I can just do mountain. And if I add some more subdivisions to my grid, we can get some more definition or detail into that mountain shape. So now you can see we have a cutting shape. If I go to the exploded view, and then again with the normal, we can do something interesting as well. So this guy can output primitive groups. And we could do maybe overlap. I think I want maybe A outside B. Let's just color these to visualize them. So again, this would be primitive. So it looks like A outside B. I think part of this too is also what I'm treating this other input as, whether it's a surface, like a grid that doesn't have a volume. If I'm doing it as a solid, it's imagining that it's like a filled in shape. So if I do surface and A polys, then those should be the the exterior points. So when I'm recalculating normals instead of this point attribute, I can do the same exclamation point. And this is saying anything that isn't already existing as those in the A polygon group. So then I can recalculate normals on the inside. So it looks good. So we can do the same thing with a grid. I'll just keep these trees a little bit organized. So 2D surface, you can see here it has the same problem that it's thinking I'm trying to fracture this like it's a volume, or it has, it's a solid surface. So if I just go to surface, now you can see this is, we're doing the same thing, but we're using that grid to cut things up. So instead of a single grid like this, we could do a scatter. Maybe we just want 30 points, and we do copy to points. That's the wrong way. So I'll just do shift, hold down the shift button and press R to reverse those inputs. And then instead of having these all lined up similarly, we can just do the attribute randomize. And instead of color, if we do N, and instead of uniform, I like to make sure this is a direction. So now you can see we could get some really natural, interesting kind of cutting patterns. So with Voronoi, we get, let me do another exploded. We get this really uniform pattern with sharp edges or hard edges all the time. But with Boolean fracture, we can get some nice natural shapes. And then all of this stuff can be used for rigid body simulations. One thing we have to be worried about, though, is when we start to simulate some of these more complex shapes. If I just grab all of those connected, usually use this assemble node, and this will just detect by connectivity which ones are attached and which ones aren't. So I can visualize that again if I color by attribute, and then my attribute will be piece, and this is all primitive stuff. Or it should be name, I'm sorry. So now we can see which ones are connected to each other. And if I press the 9 key over here, then I can select things using that name attribute instead of the individual faces like it was doing before. So if I just isolate one of these, the packed RBD solver will always try to use this shrink wrap surface, or what it calls convex hull. So you can see if you look at the icon, basically anything protruding into the shape is a concave surface. So it will turn everything into convex with no like internal shapes, or you have to be able to represent it or bound it in a simple object like that. So you can see that might cause some problems with some of these shapes. Sometimes what people do is they will do like an additional Voronoi fracture to everything. So if I just grab this tree from over there, we look at our result, and then we do an additional, this might have been a little bit too many. I'm just going to jump back and take a 0 off of that. So it's still going. I think that the Voronoi fracture process is unfortunately like a single-threaded operation. So it's a little bit slower on some CPUs or just for large fracture counts and stuff like that. So what we have is we have our, might have done that to the wrong. I want to do that after my assemble to keep my original like piece numbers. We'll wait another 20 seconds or something like that. So I can still color everything. And now you can see we have a bunch of little, mostly convex shapes. Like this one here might be a little bit of a problem, but the margin of error when it shrink wraps or converts it into a collision geometry is so small that we're doing a big effect, like something from this distance of camera. It shouldn't really matter too much. So we should be okay with that. So this is another method that people would use if they're using the Boolean fracture technique and getting some interesting shapes that might cause problems with the solver. Then you can create collision stuff like this. There's also some shelf tools inside of Houdini that are newer ones that are pretty interesting. So if you do convex decomposition Houdini, this is a nice shelf tool to know about that's doing pretty much what I was talking about. I think, yeah, so this picture or this illustration is basically the same kind of visualization where you have a big shape, but you want to represent it using a bunch of little convex shapes to help the solver know what you want to do. There's also a sphere proxy. So spheres are just naturally a convex shape. They don't have any dents or anything like that. So you can represent rigid body shapes using the same concept, but instead of fracturing it a bunch of times, you can fill it with spheres. Both of these are newer shelf tools, but they're both useful workflows, or you just use the shelf tool and kind of learn about it and pull it apart. So that's kind of where this idea comes from. And then when you're fracturing, when you're solving these, you can glue these pieces together so that you'll know, the solver will know to keep them, to treat them like they're one big piece, essentially. So this is kind of the starting points of fractures. What I want to do now is just do like an actual quick kind of example or play around with it and get some results, I guess. So we have any people in the chat have any things they want to see fractured? I was thinking about doing something with the ground plane or terrain or something like that, because we've been doing the shockwave kind of effect. So if we play around with something that's ground based like that, it might help us out. move forward, or we could include it with that effect going forward or a little bit later. So no one has any demands. I'll just get started with a terrain type of thing. So just name this example fractures. Turn off the flag to hide it. So it just wants to recook everything because I changed the name. So it's trying to just update all the results to keep that current. Thanks, guys. Yeah, I don't know. You feel free to try to distract me if you want, but otherwise I'll just kind of keep plowing ahead. So we're just going to go up to terrain effects now, and we already had like a shape that we were using in the previous scenes, but instead of pulling that in and starting with all of that, I'm just going to start with the shelf tool to kind of keep this session or this this explanation like unique, or it could stand alone kind of. Let's try the hills one and see what that gives us. So something like this could be pretty cool. Again, like I was doing in the previous one, I think I usually like to redo the height field transform. So that a trick from one of the helpful chatters. This will let you scale the size of a height field. So if I look at my reference character, and then we look at the height field, it's going to be pretty big to work with. I usually like to scale this down. If I do want this falling apart with natural gravity and stuff, I might want to go a little bit bigger. Let's lift this guy up. There he is. So something like this might be more realistic. I don't know, the other one, originally it's like a massive scale. It's almost too big sometimes. But I guess they're expecting you to add more detail and terrain, like vegetation and stuff like that, to make it realistic. But for now, we'll just play it like this is the size of the terrain relative to a human. And then this guy, I think he's like 6 feet tall, or like a little over 2 meters or something like that. Like 1.8 meters roughly in height. You go by the metric system. So if we want to fracture this, the height fields, all the height field primitives, they're not geometry. Like we don't have any polygons, we don't have any faces, we don't have a mesh, we just have volumes. So we just want to convert the height fields, whoops, not lines, to convert height field. So this one we have different options, but polygon is usually the go-to. Everything else looks pretty good. And then if I look here, now we just have all the other height fields. It's actually transferred them over to point attributes, which might be nice, because this is a digital asset that does some extra stuff underneath to preserve those other visualization, like bedrock and other masks and stuff like that. If we don't want those extra attributes, we could discard them maybe. So we could just keep only the P position attribute for right now. That's just will free up some memory or reduce the file size needed for our grid. So if you look at after we discard those extra attributes, we're at like 42 megabytes of memory needed for this file. And earlier we're up to like 46 because we were storing just all these extra values all across the grid, essentially. If we need them, we can always go in and add them back or change this attribute node to include them. And then if I want to fracture, maybe like this area here could be good. I just need to press this 9 key to get out of that group selection mode. And then if I go by points, I'm just going to grab that area right there, press delete, and then do delete non-selected. And then if I just do a sphere, then I just have a single point representing that coordinate, kind of to use as a reference if I want to. So I'm just trying to put a locator in that area, essentially. That's just a kind of a hack or a lazy way to do it. If you really want to as well, you can do like a stash node underneath. And then this will actually kind of give you your own sphere that's no longer dependent on this. So even if you are changing point counts or topology or stuff like that, you can always just, that sphere will always be there. But for right now, I think we're okay. Keeping everything live, like everything always updating. So then now what I'm going to do is maybe take this sphere, turn it into polygons, and if I just do transform and do this, that will move my entire geometry to the origin, but then I'll just do revert parameters to default. So now I have pivots and I can scale this from its origin, from its centroid, essentially. So now we have our shape, and then basically what I'm doing here is just creating cutting geometry. So if I do a Boolean, this input here, we want it to treat it as a surface, or input A. And then input B, we want to treat it as a solid. So now you see we're doing just the subtract. Instead of that, what I can do is just do an intersection. So what I'm basically doing is using this to crop in to this smaller area. So instead of fracturing everything, I'm just going to do a little kind of effect or kind of work more in a more detailed manner just on this cropped in section. So we could do, there's a couple different ways to do it, but I'm just going to make 2 of these right now. So we did intersect, and then we also have subtract. So now we have 2 different inside and outside, essentially. And we could merge them together or do other stuff like that if we need to. So let's fracture this one even more now. Probably want to do another Boolean. Boom, put that down. Again, we could do solid. What I'm going to do is actually, I want this one to have volume. So I could go into here and switch this, I think, to solid. So now we have a 2-dimensional shape, and then we have a 3-dimensional section of that terrain, essentially. And then to cut this guy up even more, just do a scatter. Again, I'll just get rid of those extra ones. If we want the points to be inside of it, the shape, instead of always on the surface, usually I'll just do VDB from polygons. And then instead of making a surface, just make a fog. So you scatter points within the fog, essentially. So you could see the difference just between those two steps. Do a grid and another copy. So I'm just replicating what I was doing earlier in the example ones. We have those, and do another randomize, do normal, and so this is why I'm always changing that. If you do uniform, everything will be positive numbers, and you'll always get these biased or facing along a specific axis line. So if you do direction, then it knows to do like a 360-degree random rotation or orientation. And I did a little bit with the RBD material fracture node. It seems nice, but I'm kind of less and less a fan of using those bigger, like higher level tools. It seems like you have less control over things when you generally use those. So you're talking about the solid fracture. So it has, which was the one that had the material, yeah. So it has the different presets in the drop-down box, which is a good way to get started with a lot of things. But usually I find, like, if I want to customize things, to jump into here is a little bit intimidating to me, or to figure out some of those. And then just for learning purposes and to have more control over everything, I prefer to try to figure things out this way, if that makes sense. The material fracture is definitely a good thing to have for quick effects and to make things realistic, like if you have limited time. But I don't know, I kind of enjoy going into the underworkings of things, I guess. If I can do my Boolean. Blakuku, how's it going? So this way you kind of, as you learn like the underworkings of these nodes, then you kind of find other places that you can apply those workflows and stuff like that. So we're doing fracturing and destruction today. It's in a sense that it's kind of related to the shockwave stuff that we were doing. It's not all continuous. Like, we're not building everything. This is meant to be a separate thing that people can jump in if they want to, or kind of take out of context. But we're doing like a fracture of a terrain section, essentially. So we have some issues here, and that's just because all of these things both are being treated as solid. So if we just go over to surface, you would see that we fixed that issue. Then the other problem right now is that these grids are sometimes too small, like they aren't always slicing through things. So you can work like that if you want, like if we do a assemble. And then if I do a color by name, you could see what I'm talking about, hopefully, with some of these grids not going all the way through. So I can just go up to, I don't want to make them super big, because then I'm like unused detail or topology. That makes sense. Like, if I make them super big, my high resolution grids won't have much effect on the terrain underneath. Like, I'm just using a small, even if these grids have a ton of points making them up, I'm only using a little bit, so I can't, it's just less optimized, I guess. You can see it's already going a little bit slowly with, I think I did like 25 grids or something like that. Let's see if we what's going on. I think the Boolean node again might be like single threaded. So a lot of these geometry modification things, whether you're slicing it up using the Voronoi fracture or chopping using the Boolean, these operations have to be multi-threaded just the way that like the operation works in the computer. It can only use one thread or one program essentially to move the points around. If you try to multi-thread things, like it could destroy or it could create things 2 times, or it's what people call like it's not a thread safe operation. So it looks like it's going, I'm just gonna hit escape and do a little bit less. I think 130 was too many. So we'll go down to 24. It looked like that one fixed it up a little bit. Then I can do another mountain just to get some more interesting cuts. We'll just look at what it is over here. So you do the element size smaller to get a more high frequency kind of displacement. Then you'll see if I do my mountain like this, I'm applying the mountain to one grid and then it's getting copied. But if I do it afterwards, then all of my mountains would be unique because I'm doing the mountain after all of the copies are created in different positions. So different offsets are being used for the noise. Might want to make some more resolution to my grids. And then it looks like this was, my element size was too big. Or too small, too high frequency, I guess. So something like this might be nice. And maybe now it will make more sense. So if I copy it after, all of these will look exactly the same. But if I do a mountain, they'll all use their unique positions to displace. So we should be a little bit better, just creating more variation or more unique kind of things. So I might want to see some more. If I do like roughness, I should see some more turbulence or just more distortion, more interesting kind of things happening. Let's try just an offset here to get a new random, a new completely unique outcome. This one could be a little bit better. I don't know about some of that stuff underneath. So just switch it up again. Something like that could be cool. Let's try it. And then if I want this to be more of a directed effect, what I can also do is just start to composite the cutting geometry. So what I mean by that is I just right now have all these random grids. But what I can do is go in with a sphere and I'm just going to take this location that things got moved to and reuse it. So now this sphere is at the center of that other sphere. We're basically just working aligned, or I've just moved it to the center, the place I was working at before. And then with these grids, I can do something else a little bit interesting, or with the spheres. Hey Kieran, how's it going? We'll do polygon, and then this time instead of copy to points, I can just do copy transform. And with the pivot, I want that to be the same centroid. So just reuse that value again. And then each copy, I want it to be slightly bigger than before. And these work, it's like a kind of exponential fashion, if you see, like, because each scale is based off of the previous one. So that's one thing to be, just to have in mind or to be careful with. So instead of linearly getting bigger by this amount each time, it's like, and then it just starts to get super, super big, if that makes sense. So I can do another mountain with these guys. Yeah, we're starting to do some RBD stuff. Talking about it in the context of terrains, so it might be a skill that will apply with the shockwave stuff. It's just a good thing to start messing around with. I don't know how it's going to get layered in or anything like that yet, though. So we'll do my mountain. I want it to be higher frequency, so I'll reduce the element size. And then I think I just need some more definition, more resolution on the spheres. And sometimes you can change the noise type. And also something to be careful about is that this mountain node will always, basically it generates a scalar value for the noise, just like one-dimensional black and white value, and moves the surface along its normal based off of that value. So you always have this kind of popcorn-looking geometry. They also have the attribute noise, where you can use this node to, I think we used it in the shockwave one to deform our emission source. But basically we can use this one to apply 3D noise to the point position. So if I increase the amplitude, I probably want to center the noise, and then make this element size bigger. You'll see this is actually doing like a 3D distortion to things. So this is more like an undulation, like a bubble or something like that, whereas this is just more, just always outwards or along the surface normal. This is just something to be concerned about when you're generating noise for geometry. So let's put this one, we'll just substitute them for right now and see what happens. So this might have been too much resolution in the geometry, too highly detailed. It will stop it. So maybe maybe 6 copies as well was too many. Let's just do 3, and we'll drop the resolution down. Then you can see kind of what I was trying to do. So what I want to do is make a bunch of little pieces in the center of this geometry, or the center of the region that we've selected to work with. And then as we move outwards, there's less, the pieces get bigger. So I think this will help us transition if I merge into the bigger shape as well. It will be less noticeable just overall, like as the pieces get bigger, and then we're not going to touch anything around the perimeter. So it should be less noticeable, essentially. If we cut this up and then we left the perimeter or whatever, like all these were uniformly sized pieces, it wouldn't look as interesting. It would look a little bit more fake. So I'll just make this I'm going to make this amplitude smaller. So we should get less like intersections and overlaps and stuff like that this way. And then the element size, we go smaller, we'll basically get smaller piece elements. Maybe my overall amplitude. So I'm just switching the flag so I can more interactively like tweak those parameters. So something like this might be useful. Let's just increase the frequency now. Maybe decrease the scaling that's happening, and then we can make some more of them. So this is kind of cool, but it's not individual pieces. Like we have big rings, but that's actually okay because when we composite or combine the two fractures, they'll interfere with each other or create new patterns essentially. So we can use kind of leverage that in our favor for this situation. So we have these smaller rings or more shapes in the center combined with our overall like shards or lines or whatever that are going through things. So if we just look at the size distribution of everything, we've got what I wanted. We have a bunch of small shapes in the middle. Going outwards, the shapes get bigger. We do have some weird stuff over here happening. So if I want, I could make another outcome or a new noise pattern with just offsetting this. Maybe something like this could be kind of cool. What I might, we're making a lot of pieces, but they're on the bottom of the shape, so you're not really going to see them if we're just fracturing the top of it. So what I might actually do is I'm going to make some groups when I fracture this. So any of this information is always accessible using these primitive groups. Sometimes it takes some time to find the right one. So if I do A inside B, that's going to be where this lighter blue shape, which is A, wherever it exists inside of the orange shape, which is B. And then if I do a blast node here, now we can work with that group. But instead of deleting it, I want to delete everything except that. And then instead of doing volumetric scatter, now all of these grids will be positioned along the surface of that shape. And then I think I can get away with some smaller grids as well. So if I just change the wiring, and then I'm just going to bypass this for now. So it's just the new grids. Should be maybe a little bit easier to see what I was doing. So I don't care if we have a big shape at the bottom right now, but I want to use more of our detail at the top there. So it's just a little bit more efficient for everything happening later on. And then even the fracture, we want to see all the detail where we're creating it. We don't want to waste a bunch of geometry and time and stuff like that, creating a bunch of rocks or stuff like that at the bottom. So this is pretty cool now. And then for the actual simulation stuff, we're going to need to work with packed geometry. So I'm not going to go too much into what that is right now, but basically it's just a more efficient way of representing each piece, or each shard becomes kind of like an instance or a self-contained when you pack it, it's basically putting it under another primitive. If you work with Maya or stuff like that, it's basically making a separate shape node or something like that. Kieran, no, I'm no longer at ILM. I actually haven't. The last movie or the last project I worked on was Solo, so it was like 2 or 3 years ago there. And then I went to Apple for a while, a couple years after that, for Apple's like commercials or advertising department. And then more recently, I've been working with a machine learning or AI company, generating some stuff for them. So if I do this pack node, we can pack everything, but now it just puts it under one shape. So if I just use my selector for primitives, we can only select the one shape. If I do by the name attribute, then I have control over all of these connected shapes that we located with the assemble. We can put them under their own primitives, essentially. So we could create packed geometry with this. It just depends on the flexibility you want. Like here, I'm coloring them and then packing them. If I wanted to, I could just do create packed geometry, and then my color, the name then becomes a point attribute. So I would need to, whoops, change that. And I think there might be an issue with coloring packed, keeping this color as a point attribute with packed primitives. We might need to then, whoops. There's like a lot of display errors sometimes with visual, like the viewport display in packed primitives. So sometimes you have to do some funky stuff. So we're gonna do from point to primitive with the color, and then we could see it that way. So I could do exploded view. My keyboard is all messed up. Exploded view, and just to get a visualization of like all the interior detail that we can kind of represent with things. Another thing that we can do now that they're packed is if you middle mouse button, you can see the total. So we have like 6,000 pieces, which should be pretty good. I can also, one of the really useful things about packed geometry is that you can work with them to move a point, and you're moving the entire object. Kind of like working at the object level of a scene, or each of these are like parented, kind of, if that makes sense. So if I just add a random value to the positions, so we'll do point position plus equals, or adds a random value to the position. It's kind of like the point jitter, essentially. That's a quick way to work with things, but if I tried to do that before I packed them, I don't have that control or whatever. So sometimes even if you're not doing a fracture, you're just doing some procedural modeling kind of stuff, packing things, doing an operation to all of the pieces can be a little bit quick, like a hack, kind of. You can also do the for loop, but sometimes just packing stuff and then unpacking it is quicker. So what I was going to show here, yeah, you can kind of make your own exploded view. It's kind of like how that works. But what I wanted to do here is basically I'm going to take these, and then I'm also going to look at that sphere that we were making that was the center. So I'm just going to do another sphere. Then this will just be one point or one primitive. And then if I look at, so we can get as a vector, basically I want to get this position of this sphere. I'll do vector C for center and set that equal to the position. So we'll do this input for input number 1, P for point position, and then 0. Just because this is always just one element or one primitive, so 0 will be sure to grab it. Now if I do P plus equals at P minus C, this is kind of like my own explosion kind of thing that I can do. So we'll do vector direction equals E minus C. And then I can multiply it by the distance that it is from that C coordinate. So now we have the points on the outside getting moved very far away, and the points near that sphere not moved very much. We can remap that using a fit function. We'll do just kind of guessing at these numbers somewhat. I know relatively the range that I'm in, but not too well. I might want this to be a little bit bigger and something like that. Might have flipped around my direction. I don't think so. So what I'm showing here is just we could make a very easy way to visualize like our own customized exploded view. So we'll get started with a simulation and going into packed RBD objects in a second. But basically I just wanted to show sometimes making these procedural deformers helps a lot in your modeling process. So like I can go back and change all of my seeds and offsets now and very quickly get like a kind of visualization or preview. If I was doing a kind of procedural effect with no simulation being used, I kind of have my own deformer that I've made using just using this simple kind of VEX codes. And sometimes to visualize stuff, we want to turn off those colors, and then the shading issues here just happen because there's no normal attributes on the geometry. So like I was saying, that's another packed primitive kind of display issue. So we just want to make a normal vector before we pack it. So if you look at the difference, you kind of see why that issue happens. So if we do this, now you can see with the lighting, shading and everything like that. Then I'll just merge it with the main mountain. So this is what I was kind of talking about when I was saying we wanted to make a bunch of smaller shapes or smaller chunks in the middle going outwards. So I can turn on this visualization again. But basically because we've fractured this a bunch of times here and then moved into larger pieces as we've gone outwards, when we turn off the color, it's very hard to know that we've done that trick or that hack to only chop up a piece of the mountain. It looks like the whole thing is individual pieces, or it just hides that little tricks or whatever cheat codes that we were doing to the geometry. We even get some lines that extend outwards, it just leads the person to believe that there's a lot more detail or whatever than there is. So that's pretty cool. We can also use these numbers and stuff for other things. So I'm gonna make a copy of this, and I'm gonna the best effects artists are the best cheaters, essentially. Joao, how's it going? So what I want to do with this one is I'm going to switch it to primitive mode. So instead of operating on points, it will operate on the packed primitives, and instead of P, I can change the color. Again, I just switched it because the packed primitives likes it to be on the color. The color attribute likes to be on primitives for the viewport. You're an advertise. Yeah, I spent some time in advertisement. It's a nice. I find it sometimes more interesting than film, just because you get new projects like every week or month, instead of spending like a year on the same film. But yeah, cheating is it's kind of fake it till you make it, or I don't know, it's an extension of that philosophy. I guess I mean I guess it kind of depends what kind of work your studio is getting, or you're assigned. I don't know, I kind of liked I guess I'm just more of a fast-paced person, but I always liked just switching it up to different projects. So I basically switched this, so we were doing a random direction masked by this fall off from the point, and now I just switched it to show the actual mask value as a color. Yeah, we're doing some fracturing. We're doing cutting up a terrain essentially, but maybe I should always have this visualized for other people just coming joining the stream. It will make a little bit more sense what's going on. So now we're looking at this as the actual, we're just visualizing the mask itself. So using this function, I'm remapping the range. Yeah, Stephen Nipping, he's super good at, it was like the he did it was like two pieces kind of drifting away from each other, like an earthquake or something like that. So basically what I'm showing here is just the visualization of that mask. You could imagine this could be useful for a bunch of different things as well. We're starting to add forces to blow this stuff up, or to do basically whatever we want to do with it. Then these values are super important, or it's just a convenient way to generate that. So basically, I'm just trying to show the usefulness of this Vex code and how you can apply it to different things. Let's get started with the .NET. This is kind of the phase one, I guess, we've completed, is modeling the fracture. I'll just save this, put it in the folder for a new day, a new stream. What is this? May? I don't know what year it is. I don't know what month it is. It's 6, I know that, and 3, June. It's June 3rd. Then I'll just do a scenes directory from. I usually don't distribute it like that, but just internally I'll work in that fashion. This is it kind of American dates? I feel like I'm saving. I usually use this numbering system. Not many people name it like this in America, but basically structuring my folders like this. Then when I sort stuff numerically in a file system or whatever, then everything will be actually like in chronological order. So that's why I'm sorting things like that. Might be the wrong way to sort things, but that's why I type it like that. Isn't it? I don't know. I feel like I've seen Europeans type it. Sometimes like that. Anyways, we saved the scene. We did something. We made some progress. So keeping things somewhat labeled. I haven't been doing a good job so far, but this will be a hook or kind of a starting point. So I'm just going to put down a null node and start to label things. It's kind of just like bookmarks or notes to yourself if you were to package this up into tools or someone else picks up the file, then it's just a little bit easier to see your starting points and kind of like waypoints or bookmarks or labels or whatever you want to call it. This is out packed fracture. So we have our 6,000 packed fragments that will pass to the DOP network. And then to get them in, we can just do the RBD packed. And before, when we were using the Pyro solver, we had to type in expressions to get the input geometry. With these, side effects has made a nice drop down, so I can just do first context and I don't need to type expressions. And then I usually like to make sure solve on creation frame. And if you want to, sometimes I'll turn off display geometry and show guide geometry. And this is kind of what I was talking about internally. What it's doing is shrink wrapping things. So if I were to go up a level and do the exploded view. So with the new RBD stuff, I haven't done too much with the constraints with 18 yet. I'm looking forward to playing around with that. It was always with rigid body stuff, there's always like so much kind of bookkeeping, or I don't know, it can get very frustrating if you aren't working in an organized manner. It's any improvements they make in that area is good for me. So what I'm just showing here is the visualization. If we spread these pieces out a little bit, and then if I go inside to compare it against the collision geometry. So hopefully that makes sense to people what I was talking about with the convex holes. That's always the geometry representation. So you just have to be mindful that that's what's happening under the hood internally with the solver. This does have other, you can tell it to use concave, but it's usually too slow to simulate if you do something like that. So I don't ever use concave. These other shapes are more optimized. So if you are doing like the sphere proxy or something, you can use these other shapes, and that would be helpful. So I'm just going to go up and turn off that now that we don't need it. And then we just need a solver. So if I do rigid body solver, you can plug it in like this. And by default, it's using Bullet. So RBD is an older internal to, it's something that side effects develop themselves that's slower, but for like hero kind of shots, like you're very concerned about bouncing and rotation of a single object, it can be useful. And then Bullet is a public publicly developed, like open source kind of simulation engine, and it's intended for games, so you can simulate thousands or even millions of pieces pretty efficiently. You don't have to worry about running too slow or anything like that. And then the other thing with RBD packed objects, where it's representing every piece as its own point, when you simulate them, it's very useful because I can use these any pop node or particle force node. If you go to pops, all of these you can use them with RBD, packed RBDs, and it will work. So if I just want to apply a noise to all of this stuff. Yeah, thanks for coming by, Joao. All of these VODs and the files and stuff like that, I make them available. So if you're just popping in for a little bit or anything, it's good to see you. So I just did a noise amplitude, and this will just apply a random force or somewhat random force to all of the pieces. So we can already see that we're getting like, this is more of an anti-gravity. We haven't applied any uniform force or anything like that. Just a quick, I don't know, it's kind of like a hello world if you're used to programming. Just to kind of kick the tires on the simulation, see what kind of speed you get, make sure everything's working. This is a good quick way or whatever to get started with that. So it looks like stuff is working, but it's quite slow. So it's even for a rigid body simulation, I don't know. I've simulated 12 frames and it took about a minute, which you expect to see something a little bit closer to the real time. So one thing that I can do, there's a few different things that I can do, but one of the things I'll usually do is create a proxy or lower resolution geometry for my bullet objects. We'll see how much that might help. So sometimes you can do like a poly reduce, but it doesn't, I don't think that's going to work or help me too much. What I can also do is delete some of the shapes that are below. We don't need to simulate all of them. So if you use this clip node with packed primitives, this is just a good way to basically say we're separating points inside or outside of a specific plane. So anything with its centroid beneath this value, it will delete them. If you do all primitives, then you can create groups, and then I can split them. So do split, and above plane, something happened. Didn't like it. Somehow it's not assigning my groups. All right, I'm not going to do that. Instead, you could just do the position directly. So if I do at p.y, I can compare that to a value. Let me go back real quick. Just going to Control Z a couple times. All right, I just wanted to double check, but maybe this group type was the wrong field, but it doesn't look like that was the case. So I could just copy this value and use it more directly within here. So if I do the Y position is greater than negative 0.75, keep it or put it into this input. Everything below it will go into this input. So by doing that, I'm going from 6,000 points or 6,000 pieces, packed RBDs. And then I might need to plug it into this one here. Somehow it's still, so maybe that was only like 50 pieces, but because they were pretty big, it should help me speed things up a little bit. See how much I can get away with. So I'm just trying to move this as close as possible without getting rid of any of the surface points. So now we're below 6,000. Now we can try our simulation another time, a second time, and see if we made some speed gains. So it looks it looks like things are still a little bit slow. What I'm going to do is just go up to our fracture and try to optimize this stuff a little bit more. So if I cut my shapes here with lower resolution grids, the resulting topology after the Boolean will be less dense, essentially, or a lower resolution. The same idea with these spheres, or the nested spheres that I'm creating here. And then maybe instead of 6, we'll just do 4 of them. We'll just take a look and see what we get there. So now we're a little bit under 2,000. But everything, because we've set everything up with Houdini or Smartly, we could go back to a higher resolution and just switch things out on the fly if we needed. But basically, because I want to do this live or quickly, I'm cheating some more. So we're getting a little bit quicker results, maybe a second or 2 seconds, maybe closer to 5 seconds for each frame, but we're still in better shape than we were before. So we know we can use this force to move things around. This is like the anti-gravity spinning effect. Actually, I'll just play this and let it cache maybe like 20 or 30 seconds. I'm gonna get some water and I'll be right back. All right. So you can see another thing is happening too, which is the simulation is speeding up quite a bit as well. So that's happening because as we're calculating less collisions for each time step, the overall time that the solver needs to compute each frame decreases. So that's another benefit, or whatever you want to think of it as. We have some unnatural things happening with these larger pieces. They just look kind of cartoony shapes, but overall everything seems to be working how we would expect it. But this force again is so it's just an anti-gravity kind of effect. If I made my swirl size a lot bigger, this will give us like a lower frequency noise, so everything could look a little bit more uniform. One thing you can do with this is, like, if you make a group of these pieces, you could like gradually apply this force to something, like it's getting pulled or split apart or something like that. Yeah, the weird shapes can be interesting. It's always depends on the look, if you have an art director or concept, but you can You can definitely use it even just for like procedural modeling and stuff like that and get some nice shapes with it. So basically what I'm showing with this is you do this a bigger swirl size and now you have like a more coherent kind of overall force or whatever to move things around with. So instead of all of this, we can do no noise-based force or like wind or anti-gravity or whatever. We'll just do negative 9.8 just for the default world gravity or Earth style gravity. I can just rename this to gravity, and now when I play it, everything falls, which isn't necessarily what we're after. So to fix that, what we can do is just make some of these pieces inactive so that they are treated as like static objects. With Houdini, that used to be a lot bigger of a task than it sounded like, but again, luckily with these RBD packed objects, we can control not only forces like this with pop nodes, but we can control a bunch of different things with point attributes. So create active objects. This can be set or overridden with a point attribute. Right now we can leave it to create active objects. But if I go back to this visualization, what I can basically do with this is I only want the white ones to be active. So you just want to adjust the numbers a little bit until there we are, just closer to the center. And then instead of color, I want this to be integer for I for integer and active. So we see our color visualization goes away, but now we have this primitive attribute. It's called active. And instead of primitive, we want that to be a point attribute. So now when I go ahead and play my simulation, see everything's happening a little bit quicker because we have some inactive things that it doesn't have to worry about them rubbing up against each other or colliding as much. And overall, nothing's really moving. We do have our center kind of falling apart or crumbling or whatever, but we don't need to worry about that for right now. And then if we want something interesting happening at the top here, we can start to add force attributes or velocity, essentially. So we'll just try to keep things somewhat organized. This guy just has a warning symbol right here because this mask is generating float values or numbers that are between 0 and 1, like decimals, and I'm telling it to assign the value to an integer. So it's just saying going from float to integer, do it explicitly instead, so I'll stop yelling at you. So if I want it to stop yelling at me, I can just do int right here. And then he's happy with me. So if I want to assign velocities, we can start to do a similar technique that we did with that the shockwave dust kind of thing, where I was looking at the difference between the original positions and then their moved positions. Just gonna make another copy of this transform. So I was moving this around to kind of like a slingshot again or whatever. Let me just get these translations happening from the Centroid. So as I move the middle of this around, it's kind of like a slingshot. So it's going from the center of this sphere to a displaced direction, and the more that I pull it back, like drop it down, things will want to shoot upwards, essentially. I can change these things here, like the distance, everything's moving, using, again, this is like the mask attribute that I made, or the value. We want more of these things moving, maybe something like that. I don't need to worry about these ones on the edge because I've either deleted them or set them to inactive. We could just keep going, playing around with these values. Sometimes what I also like to do is I'll use an exponent. So we just do power. We could set the exponent here. So if we do, this is kind of like a gamma or contrast or something like that. The higher I make that, then we'll just get like super big values towards the middle of this function. But as it decreases, those numbers will decrease more quickly. And then if I want to just overall accentuate this more, I can multiply it. Kieran, good to see you. Yeah, have a good night. It's like 4 a.m. or something for your time. So now you could hopefully kind of see what this power function is doing. If I go closer with these values, maybe it makes a little bit more sense. Maybe this guy. So if I just do power of 1 for linear, I think my fall off is two clamps now. So a power of 1 versus a power of 7. So we're basically either just doing like very high values with a dramatic fall off, like super far distances compared to super close distances, or if we don't do a power, just use a power of 1, it would just be more of a linear fall off from the center of this mask coordinate. So maybe something like a power of 2, multiply it by 15, then you start to get some of those chunks. Maybe a bigger range or something like that. And then instead of moving them in this direction, I'll just do the velocity equals this direction. Sometimes what I'll do to visualize things is just use this add SOP and do delete geometry but keep points. So now I just have a point cloud that represents the center of all of the packed RBD or packed objects. And then if I visualize the velocity vectors, it becomes just easier to make sense of what's going on. So without that, you can see we can't really see the velocity vectors. You can go into like wireframe mode maybe, but even that, it's a little bit hard to separate the velocity vectors from the edge wires. So sometimes I'll just do this visualization like this method. And depending on the way you want to work, you can split this up different ways. Doing this attribute copy, sometimes I like to work this way. So because my point count and point order is the same, I can just transfer or copy over the velocity vectors from this input. So I have another chain of soft nodes over here that I can visualize pretty easily. And then just the resulting information that I need is copied back onto the main chain of all the work that I'm doing. So do copy V, calculate outward V, and this one just do only points. If you want to visualize things again, because this is all packed, we could just do like at p plus equals the velocity. So we're just moving these along their velocity vector just to make sure that we've got the velocities and they're working as expected. If this was like a mismatched point number, so if I did sort and random, then I could kind of more quickly tell that something had gone wrong before wasting time with a simulation or something like that. And then the last thing, so this one we're able to override it just by setting the active attribute. But to use velocities, we just need to tell it to use that information from the RBDs. And then because I have solve on creation frame enabled, you can see things already started to move a little bit. So we could just let this play and we have something. It's passable. This is like you hit something with a tiny hammer, but it wasn't enough force or something like that. We still have those guys falling down, but we don't need to worry about them still. So we can just go up here and we have this pretty easy way to visualize things. And if I want to keep my chain down here, I can even visualize like the predicted movement of things almost. So if I increase this overall amount, that's one way that we can blow things out further. Also, this visualization, you maybe want to divide this number by 24 or whatever your frames per second are. You can also just do $FPS. That will get the actual number that's set globally. This way it will basically, the velocities are decoupled from your playback speed. So if you do it, then this is like more realistically the predicted position after one frame or one time step, if that makes sense. It's kind of a convoluted explanation. But this way I'm just basically saying my numbers that I'm typing in here should be a little bit more accurate or precise. So I'm moving the sphere down so I can shoot things up. The higher that I move it, then the more outwards I can blow everything up or move everything essentially. And then I'm just going to change the limit or the distance that things are going to move. Maybe I'll do the power, increase the power function so things are just more concentrated at the center of my proximity distance fall off thing that I'm doing up here. Let me just play with these numbers a little bit. All right, let's give this a try. See what happens. So you can see even with this, I'm just doing it over here because we don't need to do a simulation, but because I've set this to solve on creation frame, we can already see how far these move after one frame. So now we have like a pretty big explosion. Sometimes what I'll do down here is just start to do some visualization stuff. So if I do rename primitive and get rid of the color, and we can move this wire all the way down. And then we're already in good shape and we can do like, should something happen? this is over here, and somehow this shifted. Let me just double check we've done everything right. So I think maybe too many things are active, and it doesn't look like that's the case. Just gonna reset simulation to try to see if it was like a problem. Somehow everything's moving. Doesn't make sense. That could have been a display port viewport error. I don't know. If anyone in the chat knows, feel free to help me out with that one. So we can merge things together this way because this is such a high point count over here. This merge operation is happening every frame. It's going to be a little bit slow because we're basically doing the simulation. Ooh, why is that happening? This could be another like packed primitive display error. So what I'm going to do after this step right here, I'm just going to do an unpack. It's just like a brute force way of kind of correcting that problem. And then what I was talking about with the merge node is this is like actually an operation that takes some time to do each frame. So instead of doing that actual operation, if I just do the control template flag, we can cut that node, that cook time out of the loop. Things will be a little bit quicker. Man, stuff is still moving around. Let's investigate here. Doesn't make any sense. Like this main mountain shape is moving. So this, oh, I know what's happening. So there's this erosion solver that they added. Everything is a time-based operation. And this is kind of what I was talking about. I forgot to do it. But you can either write this geometry out to disk, or if you just do a time shift node, you can basically just do a frame hold operation. If I delete that channel, this will basically say only just keep everything at frame 1, and now my other operations will happen a little bit quicker. It was a unfortunate blunder on my part. And then now what's happening with this merge is that there's no normals on my ground plane, the terrain. Not noise, but no normals. So if we add normals, then we can, now we're getting like the expected results. All right, we fixed everything. So I could do a flipbook animation. Let's just run a quick visualization of what's happening. So this can be useful when you're doing simulations, because if you run a flipbook, then you can play stuff back and you're sure that everything's running at real time or 24 frames a second. So we can see we have some guys, some butterflies spinning around a little bit too much. Maybe my gravity is too low or something. It's a little bit weird how that guy's hanging in the air for so long. We have some cool stuff happening here where it's just the initial punch or force, and then we have like some cracked edges that are getting revealed. And then of course the ground plane, the rest of the terrain isn't part of the simulation yet, so it's just everything's going through it. And then maybe our initial force might be too high, so I'll just back out of that, go into a wider view. This is like a big destruction, so our force might just be too much. We go into our velocity calculation, maybe go back to 15 and just play this, and this might be a little bit more realistic. This is a little bit cooler. I can get rid of this unpack, so I don't need to worry about that error or the mistake I was doing earlier. And then this is what I'm saying about just playing things back this way. You can see I'm getting like a real-time playback after the simulation's cooked, just because I'm not unpacking and merging. Those extra operations take more time. So something like this is a pretty cool pattern. Might just go up to this. I'm gonna change my like interior radius, so we should just have more of a concentrated force that falls off more smoothly, essentially. So something like this could be pretty cool. So save this just as another version, just in case we lose power, or if we lose power, we lose the stream. It would be a nightmare situation. But just save the progress. One thing I haven't tried, but I'm curious to see if it works. If we can still use this terrain object to simulate height fields with the static object workflow. So what I would need to do is, instead of this being a Boolean object, I need to do a height field operation that would push that center down by the same amount of that sphere. I think I can also do it this way. This is another not intended use of Houdini, or not intended use of the height field nodes, but we'll just go and see what happens. So I'm going to plug the height field into this first input, and then I'm going to make another copy of the Boolean, and this time instead of surface I'm going to do a solid, and then with this height field what I can do is have it look at the this geometry and change the height value until it matches that of this position with the hole cut out from it. So basically this uses the height volume. So if I set it to 0, then you can see everything has just become completely flat. So using this height, we can procedurally change the the values or the elevation of our terrain. I can also do like plus equals a noise based on the position. And you can distort things, you do fancy things that way. But what I want to do is basically just assign it to the elevation of this terrain. So I think I'm going to do a couple of steps here. I'm going to take the like mesh polygon version. Then I'm going to do the ray node. And then if I do reverse rays, it's going to project the height field down inside of that sphere. And then I think instead of doing it from the normal, I just want to do it based off of the vector. And just set that to be straight down or -1. And then I don't need to reverse the rays anymore. So now we can see what results we get. Then I'm just going to put the rest position to make a copy of the coordinates before we project them. Then I can do with a wrangle. I can just say it's going to get pretty sloppy. This is I'm doing too many steps, I think, than I should be doing. What I'm going to do is I'm just going to put the height into a new attribute called height. So we'll take the Y position and copy it into height. And then I'm making that copy, or I'm storing it so that I can go back with this swap. Move the attributes back to where they were, move the point attribute back to where it was. So we'll swap P with the rest. And then with this guy, instead of moving it by noise, what I can do is just set it to the height value of the nearest point position that it finds. And then we kind of have something close to what we're doing. So I don't know if this is a sanctioned, side effect certified method to do it, but I didn't want to waste a bunch of time trying out things that I didn't know worked that well. So I just went ahead and I don't know. Like if you're stuck in a forest, you just break out the machete and hack all the brush and everything aside. It's not the best method, but it gets it done. So now I can put this in using the height field. I just want to take the path of the second input of this node, of the parent of this node, so the DOP network. So I do 1, it's like the second input or index number 1. And now I can merge these. So the reason why I was like hacking everything together so quickly is I'm not 100% sure if this packed RBD stuff can collide with a height field. So I just wanted to very quickly get a result that was working before wasting a bunch of everyone's time figuring out how to do that height field operation, and then it didn't work and it would have been a complete blunder. So let's see once these guys roll through if they have the correct response to the height field. So it looks like it's working. It looks like we did it properly. We succeeded. So let's add some more force, maybe. So just to get these things like shooting out. Again, we can go back to what I was talking about with this slingshot method, and instead of syncing this force like location, instead of having it down, the higher we move it, the more outward kind of trajectories we'll get for all these shapes. So this could be a little bit big, but we'll just see what happens. We do have some guys that are falling through, but we don't need to worry about them right now. This looks pretty good. I'm just gonna switch this so it's not getting the height field. So if I just do RBD, we'll only get the rigid body objects. And then we can switch back to this visualization method that we were doing. And now we have what we're kind of trying to get, where the entire terrain is a static object. And then basically we've just activated and cut up the center region and said, this is only the area we want to spend time working on creating detail in. So we'll optimize everything to be represented that way, essentially. Looks like maybe we want some more of that stuff to be movable or activated. I'm also just going to go in here and get rid of my solve on creation frame, so we can make sure that we have a like undeformed mountain on the first frame, so it looks a little bit more interesting. Let's go up here to my velocity calculation and maybe start to use a bigger range with less of an exponent. I'm just trying to include some more of those pieces. So some of these guys look a little bit weird how they're flying out. There's a couple bunch of different things that I'm noticing. One thing is that some of these are just staying completely flat and they aren't spinning at all. So we can actually change that. The V velocity is just like directional movement, but there's also an RBD attribute. Instead of velocity, there's like this angular velocity. And this, you can modify it with a point attribute that's called W. So velocity is V and angular velocity is W. So if I go up here to randomize, right now it's doing color, so that's why it changed that output at the end. If I do W, and then again, instead of uniform, I probably want that to be direction. Sometimes I'll just set the value to something really high to make sure that it's working. So I think it's I think it's working. Let's go a little bit smaller, just to 5. So I think this number can be a little bit misleading. So I think it's like rotation might be in degrees and it might be like per second. But basically it's just a number that needs to be usually higher than you think it needs to be. But now we can see that that big chunk is actually rotating. So I think we've done what we needed to with this one, the W. This will just be random angular velocity. Just keep it as V. Maybe I'll just say W. If I want to really like make this clear, sometimes I'll do comments and just do angular velocity is W. So this attribute is just a little bit hidden, like not everyone knows about it. So if someone else was picking up this file, then they might be like, what is he doing with this W? I've never seen this value before. I don't know what it does. There's also, I think I've showed you guys this before, but my like older website, there's the one page of it that's just this Vex Wrangle cheat sheet. It's pretty much the only useful information on that website. But if you go to DOP particle attributes, you can see that there's this W, as I've kind of labeled in there. If you go to packed RBD objects, you might not see that W attribute, but that's because any DOP particle attribute you can also set and like modify, and it will affect the RBDs. Similarly to these pop force nodes that you can use to control RBDs, the same thing with the particle attributes. So now we have some nice ways to control the rotations of things to be a little bit more realistic. And then some of these are going way too fast. So that's what the first time I did a flip book, that's what I was calling like the butterflies, kind of like they're flapping their wings really quickly. That just always breaks the scale, or just is an immediate thing that you're like, that doesn't look realistic at all. So it's definitely something, the first time you show it to an art director or supervisor or whatever, they'll say, fix that. What are you doing with that sparkling piece that's rotating around so quickly? So there's a couple ways to go about fixing those. I think one thing you can do, whoops, I jumped around. One thing you can do, again, using the pop nodes, they have the speed limit node. And this guy, besides speed, you can also clamp the minimum and maximum spin or strength of the rotations. So if I put this in and play the simulation again, now you can see everything is kind of subdued quite a bit. So even that thing that had some nice stuff at the start, we lost it. We kind of clamped the spin values. What we can do is make it bigger. So if I clamp everything at like 15, I don't know if it might be like meters rotate. The hard angular velocity is a hard thing to describe the units of. But now you can see that we've kind of gotten rid of, or we've made sure that nothing is spinning faster than this limit or this speed. So that's definitely a useful thing to do. You can also do the pop drag spin. But with this one, I've found that the spin resistance numbers, when this one you have to use really small numbers, otherwise it kind of blows up your simulation. So like maybe if I try 7, some of these smaller pieces will explode off or zoom way off. I don't know if it's... That guy might be related. I'm not sure. But I would just say with this spin resistance one, like try a super low number or something like that when you're getting started. It might also have to do with whether you've clamped your speeds or not. It can have like a weird unintentional effect and just somehow introduce super fast spins into your simulation. But now you can kind of see, even though I've disabled the speed limit, we've fixed is just another method of fixing those pieces that are spinning out of control. Boom, boom, boom. We fix them. So you could do both of these or either one of these, anything like that to fix some of those problems. We can also just do pop drag. And this one we can do just an overall drag on the just regular velocity. Instead of angular velocity, this is like linear velocity or directional force. You can kind of see now that initial explosion force is very quickly getting dampened. So this is another one you might want to use smaller numbers with. And then this way, it kind of adds like a sense of scale to our scene. If these mountain or rocks are pretty big, you would expect them to stop or like slow down more quickly. Whenever you see stuff with drag like that, it kind of gives it some more weight to it. So you would think that these rocks are like, if I'm shooting them and they're rotating really fast and moving around really fast, it looks like a little model of a mountain. But if it's a huge explosion, then you would expect these to move slower. So it looks like playing this back, my rotations are still a little too fast in some areas. So you might want to clamp that value down to be a little bit lower. We're at 15. Let's try 6. And let's try another flip book. So now you can see instead of those big ones whipping around, we've gotten them more under control. So again, that just has to do with the sense of scale that I was talking about. Some of these are maybe too fast, but overall, it's just looking a lot more realistic, or like a bigger destruction or a bigger event overall that we've created. So I might want to go up here, and maybe the outward velocity, multiplying that by 25 might be too high. So we'll just go to like 12, close to half. And just gonna move our camera in a little bit closer and do another flip book. So now you can kind of see what I'm talking about as stuff is just moving slower, traveling less of a distance in longer time. It seems to have more weight to it. This kind of rotation there is a little bit funky. With bullet and packed RBD especially, you always get like some weird rotations like that. Sometimes just regenerating like a random seed or random numbers can kind of fix it. It's possible I might also just want to cut these pieces up to somewhat be smaller in general. But lucky for us, we've set everything up in a very like controllable fashion. So now that we have everything tested and we know that it works, we can get to a little bit closer of a resolution than I tried at the start of the stream. So if folks were in the chat or you remember from maybe an hour and a half ago or something, initially my shapes, I was generating too many fractured objects. After I packed it, I was up to like 6,000, and I took that value down just to get things playing back a little bit more interactively. So basically, if I make these spheres, more copies of them, maybe the outward, the amounts that they increase is less for each iteration or each copy. And then just the overall resolution, go a little bit higher with them. If I want to, I can just visualize that portion of things. So this is kind of what I'm talking about, is just more detail in this area. Maybe I'll reduce the uniform scale before I start copying them. And then my copies can get increasingly bigger to just have a better distribution that way. Should be just try it out with everything and see what happens. So now we're at like 3,500 pieces that we're creating. We might want to go a little bit higher resolution with these grids. So as I'm increasing the resolution, that like I can get more finely displaced surfaces, and the result of that will basically allow me to create tinier pieces, and the just overall edge detail will be smoother. Because when I chop things up with these, the cut, like these lines here, I can just represent more detail or more fine detail with them. So now we're still like 4,000. Still might be somewhat low. So what I'm going to do with these spheres, you look at the wireframe, it's like little insides of the earth or something like that. Instead of this distribution, I'll just go so that they're increasing less per iteration and create more of them overall. So then when I distort them, they should be a little bit different. I'm gonna try something else too. So if I do a for each connected piece, then I can basically run. This might be too many nodes. I don't know if I want to do that. So I'm trying to basically do a unique noise offset per copy. Let me see if I can do. So this is copy num will create this primitive attribute. And then if I do my for each named piece, then I can use the copy num. So I think I typed it. Oof. Sometimes side effects does it's called like camel case. Sometimes they do it, sometimes they don't. And then this will allow me to access the iteration value. So this guy here creates detail attributes, and each time I run this, it will generate the incremental iteration number. So I can just move that over there. Then usually I do this spare input. Then I can just reference that metadata or meta value by dragging and dropping. You'll see that it makes, just get rid of those, I don't need them. This makes a little line just basically illustrating that reference. And then these spare inputs, you just reference them with negative numbers. So I can do like a random offset based off of, it's actually a detail attribute, and -1 for spare input 0. It's a little counterintuitive. We'll just keep going. Iteration to get that attribute. And then the last one is basically the default number or it's the component. So if this was a 3D vector, it had more values. But for that, we can just do 0, because it's just a float or an integer value. Just a one-dimensional number. And then if I just multiply this by a really high number, now you can see that I'm getting random offsets, or the noise is different with each copy. So if I just Control X to cut that and go back to 0, all of these are lining up. Kind of all of the noise patterns are in the same, using the same coordinates. We go back. Now we just have more interesting overlaps happening. Maybe I want more noise roughness. Just trying to get some more detail happening. Then let's just go into just visualize this solo or by itself. Turn off the wireframe. Now you can see we have just a lot more pieces overall. Maybe not like numerically, but just visually, we have a lot more detail. All right, well, I think we do have more pieces numerically, but I just forgot to include the other grids. So let's see how many we have after I merge this one in. You guys think over under 10,000? I'm going to say over 10,000 pieces. Is that right? I guess it might still be pretty optimized. I don't know if I trust that number. Something could be amiss. So just try another simulation with it and see if things look better. I think we did it. We made things look better without really adding a lot more slowness or data to our simulation. So that's definitely a good step. So if we start to find some interesting views, sometimes I'll just start to make cameras. So just Control click to put down a camera. Just save that current view to a camera. And then I'm just going to increase the detail on some of these guys. So because everything was running so quickly, I'm just going to add more resolution to this mesh for these grids. And then this should let us get like just even more detail into these edges as they get cut. So give this a try. I'm just going to save it again. Go up to version 3, and then everything should cook. So this is like, we're hitting the 2.5 hour mark or close to it. I'll probably just get into some flip books of this higher resolution simulation, and then that should be a pretty good stopping point. Like, keep it under the 2.5 hour mark or close to it. So because I increased the resolution of those grids, the Boolean operation is going to take longer to calculate because it's just more geometry. And then it's also going to create more pieces because you have more definition in those cutters. There will be more smaller intricate overlaps. So just more little pieces will be generated overall. I might have increased things by too much, but we'll give it a little bit longer to see what happens. So unfortunately, this the Boolean is just a CPU node. We can't use OpenCL or fancy GPU stuff like we were doing with the Shockwave. So we're at a minute or a little bit more than a minute of cook time. I'll give it a little bit longer. Sometimes what people will do to kind of multi-thread things, like I was saying earlier, the Boolean isn't multi-threaded, but you could do like an initial kind of segmentation to create like 8 different fractures, and then run all of those in parallel using PDG or just as separate processes. Like you run 8 Houdini sessions at once that all refine those segments or kind of containers or whatever. So that's a more advanced trick or whatever if you really want to create a lot of geometry in a multi-threaded manner. It looks like this guy's taking a little bit too long. I'm just going to bail. And it's just these grids here are too much detail. So we'll just go 120. And see what happens with that. Try to get rid of all these error flags. It's always an embarrassment to have those guys all over the place. Someone comes over to your desk and you just try to unplug your monitor, rip the plug out, turn it off. Don't look at it. So we're almost at a minute. I have a little bit more faith in this one. We should be able to keep the fracture process under 2 minutes. We did it. So if you want to check, you can just middle mouse on that. You see it's like 50 seconds, which isn't terrible. And then I'm sure some of these other operations took some time. So now we can go back into our camera, back into just our visualization, and just reset the simulation to clean up those errors, and just give this another flip book. So using those masks and everything like that is a super nice way to work with these things, because even as my inputs change, I can up-res, adjust parameters and all of that stuff very quickly without having to do those manual steps of like setting up force centroids or force directions. This is a really good way to set things up like in an art directable but procedural manner. So a really useful skill to have. So I could go in, and if I had a render farm or a more robust one or something like that, just launch like 20 different resolutions and see which one looks the best, or see which one finishes in a day, and go with that one. I don't know. It's the intrigue of Houdini. So we're starting to get something pretty realistic, pretty cool. One thing I might do, if I were to keep, maybe I'll try to sneak it in under the time limit, 2.5 hours, but it's a little bit weird, I think, how all of this stuff is such a clean line. Like, it might be cool to see some smaller pieces going higher or going further or something like that. So what I'm going to do with my velocities, we go back to our visualization. Can do a few different things. I might just do this attribute randomize. And then I'm just going to generate a random velocity vector, which I'll add to these points. I think it's trying to cook that longer. I might have screwed myself. Thought I could get it in under the time limit. So it's usually a good idea, I guess, to save or to cache out some of that geometry, so that this kind of blunder, the classic blunder, doesn't happen. But what I'm going to do is add some random directions to these velocities, just so that it isn't like uniformly radial outward directional movement. We'll have some stuff crisscrossing, and then we'll also hopefully get some different magnitudes overall because of it. So I'll just do direction, velocity, and then instead of set or overwriting, I'll add to it. And then as I increase this, you can see that these all get a little bit random. Even the ones on the outside, but maybe that's okay. Maybe it's something that we like. We'll take a look and see what happens. There's also some other ideas I have to introduce a little bit more randomness, or basically, like, we have all these shapes, but because this line is so visible, I think it would just look more detailed or more impressive if we were able to shoot some guys up that are leading the others or whatever. So we did have some here that are kind of, we broke up that smooth line. I'm just going to go in and add a little bit more. So with this one here, we have our velocities, and then we do velocity multiplied by a random number based off of the point position. Then you can see that they all get different lengths. So we had uniform, everything kind of near each other gets a similar direction and magnitude. This way we can apply some randomness to the magnitudes. And then I think I'm just going to make sure that this is a float. So instead of moving them in different directions, it's just going to scale the speeds or the overall amount that it's adjusting them. And then if I just add 1 to this will only make some bigger than others. Like, it doesn't make any shorter. So it's either going to multiply them by 1 or values higher than 1, between 1 and 2 in this case. This might be a good area to use the power function again. So if I do everything with a power of 2, as I change that exponent, basically more of them will get values of 1 and less of them will get higher numbers. If I do a power of 7, you can see we're getting a very subtle difference, but just some of them are going to have their lengths doubled. If I do this way, just a power of 1, or basically ignoring the power, they all get evenly distributed extensions of their magnitude. But this way we have more contrast or kind of interest. So just a few of them get the speed boost. And then maybe if I multiply this by 4, just some of them should get super big changes. So again, I'll just comment and uncomment this to visualize. So we did that, and then we just take a few of them and shoot them at give them a super big speed boost. So let's go back to our camera and hope it works. See if this is the success that will make it a final end of stream effect. It's looking promising. So that is what I was talking about by breaking up this line right here. Instead of this boring kind of flat explosion, we adjust the velocities to get just some more interest overall. Could be a little bit over the top, like some of them might break the scale because they're moving too far, but I don't know. I think it looks more dynamic, more interesting overall. So this is a pretty good starting point, or I guess endpoint for today's stream. But if you were to do a kind of ground-based explosion or shockwave, pretty interesting. You guys put your minds to it, you could probably think up some other ways to apply these techniques. So instead of like isolating a patch of the terrain like this, you could like chop off the tops of these mountains and then maybe change just the active attribute to like roll some down, like a avalanche or earthquake or something like that. You could do a bunch of different stuff. Even these, instead of shooting them up in the air, you could just kind of let them fall down. Like there's just a ground tremor or something like that that's releasing or freeing some of these guys from, I don't know, it's like a earthquake or tectonic shift or something like that. So I'll let this simulate out or continue the simulation, but we're in good shape with the overall speed of performance of the simulation. It's we're getting like, I don't know, an average maybe of a frame per 3 seconds, which is pretty nice. If you guys have any questions or comments before we wrap it up, feel free to, now's your chance. As far as the schedule, we'll probably be back on Friday, going back to the dust or smoke type kind of effects. Yeah, I don't know, maybe I'm moving moving too fast for people. Some guy on YouTube was like, there's too much, I don't have enough time to go through all of these. It's like making these at too fast of a speed for people. I don't know if I'm going to take a break or I don't know. I still am working on like the cadence and scope that these go in. What I'm trying to do right now is focus just on like destruction. So we have some smoke effects that we're working on, and then we have some RBD, and I don't know, people can think of interesting ways to combine them or repurpose those skills into like new effects, hopefully. So we got a more interesting pattern. The other reason I was so concerned about that shape is that if you do like streak dust or smoke behind those shapes, like you'll get a much more interesting silhouette as stuff explodes, instead of like that boring, just like very controlled type of explosion. Yeah, I don't know. So like, if like, so I've gotten offers for the other online vendors that sell educational content, but their business models I wasn't too happy with. So he's asking how. No, I understand your English just fine. Um, he's asking how come we're doing the streams instead of selling. So I already have a job like full time doing this kind of stuff, and I make enough money from that to support my life, my lifestyle. Um, I don't know. I'm just trying to build up more of a community or an audience here where we can share knowledge or techniques or stuff like that. And then at some point in the future, if I did release things like independently, there would be a bigger audience for everyone to buy the tutorial like directly through me, instead of if I released it like through a CG Masters or Gnomon or something like that. They tell you more of a focused curriculum that you would have to follow, or and then just like the profit model is not that intriguing for individual people. I think you also lose control over the IP or the intellectual property of the tutorial. And they could like, in future semesters, they could just hire another person to explain your content and kind of like babysit people through it. But yeah, I don't know. A long story short, it's a bunch of reasons like that why I wanted to do this. And then just like with Twitch, it's just a newer technology that I think is pretty interesting. Being able to do Houdini, like real time kind of stuff like this, is something I just wanted to try out. So we're at a pretty good stopping point. We got a good effect. So I'll save this file in my directory, upload it to the usual places. It also has those examples in the other geometry object that I went over for the first half hour or whatever of the stream. So that's a very good place to start with, or just practice, see what kind of patterns, interesting shatters and cuts and fractures and stuff like that you can make. Yeah, so we'll probably end it here. See you guys on Friday, most likely.